I started out printing the vanes. I don't think they're gonna hold. That's gonna be too thin, it's gonna topple over. I'm gonna have to redo this. Once they're up, like, they're gonna be up that high, there's no way that's gonna adhere to the bed. So this is one vane. I gotta print 6 of these. And it's imperative that the design be just right on. Not the design, but the print. See? One of the edges is rounded off and the other one's flat. The rounded off edge is where the seal is going to be made to the stator ring housing, right? This side is rounded off. This is the stator ring printing. And by the looks of it, the filament fan is on and the extruder fan is on. I put it at, I think it's 20% infill. I don't want to spend all my PLA and it's not even going to be anything else but for testing. And these are my settings for PLA. This is the completed stator ring. And this is the little vanes. There's 6 of them. And the round surface goes on the ring to provide a seal, right? If it was square, there might be some leakage, but since it's round. And I had printed 6 of these things, right? So they're all going to be going around in a circle. So if your stator in the middle is not in the center and it's to one side, that means there's going to be expansion and then compression. And that's what you need for a pump. Yeah, this is support material. Because it's not full. Normally on a full piece you would see a solid layer or 3 or 4 layers for the outer shell, right? It's just printing supports.
So there's a lot of infill, and that's just for supports. 20% done. 100% fan, 100% feed rate of whatever it was set to.
It's now printing the input shaft. The input shaft of the stator. This is that's at 20% infill, and it looks like it has 3 or 4 outer layers. Like I said, it's not something that has to be really super strong. It's just proof of concept, right? And right there, if you can see it, you're going to see the hole for the fluid to go through, and in the middle, that's where the shaft is going to go through. I'm at 60%, 63% of the print, and this is the output, I believe, because there's only one hole over here for the fluid to come out. There's no shaft. Shaft hole. And I noticed one thing. Once your spool gets down to the low level, if your filament binds or isn't like loosened up a little bit, it binds, and this this servo right here pulls that in, and then starts spinning in a void on the same piece of wire, and your printer doesn't know it. It keeps on printing, but there's nothing coming out. So this is okay when you run out of filament, but even at that, and it can't come out here to for the laser to pick it up and say, well, there's no more filament, stop the print, right? So you and you got to make sure that this is loose, right? So it can unwind itself with no hang-ups. 64%, 250. This is a PLA. Oh, the maker is it's not Overture. It's Amazon 3D, right? See? I don't know if you can see that. See the light in the hole? That's gonna be my inlet, right? And I gotta remove this plug here, and this is gonna be for my shaft from the stator, right? I made this shaft so it would fit in a drill chuck. The other end here will be fitting in this section here, in this piece here where I have to remove this filler material. As you can see, there's the outlet, and that passageway right there is where the compressed fluid is going to be coming out. Now, one thing about a vane pump, if you reduce the passageway on the output or the input, volumes of water move in a different manner, and eventually you might create what is called cavitation. And to get maximum efficiency out of a pump, okay, for every revolution you want the same volume going out that's going in. That's important, and that's got nothing to do with a balanced or unbalanced vane pump. But for maximum efficiency of a pump, you want to make sure that, let's say this exhaust port can move, this is just an example, like 1 cubic inch of water per revolution. Well, you want to make sure that you can intake 1 square inch of water per revolution. You know, if there's any kind of imbalance, you're probably going to create cavitation or cause high power consumption and excess force on the motor, or the motor will have to work twice as hard, right? So that's going to cost you in electricity. This is the inlet cover. That's the amount of infill. And as you can see by the size of that opening, the center is the shaft and the other part is the opening. I couldn't get the Fusion 360 to loft that opening properly. It always showed me an error, so I must have been doing something wrong. But I ended up doing, I think I lofted it just the same, but my opening for the intake inside the pump is larger than the outlet of the pump. See, whatever's laying flat, like whatever's touching the tape from the other side, that's the size of the opening, and it's obviously bigger than the inlet, than the outlet, sorry. So I'm going to have an unbalanced pump and probably some cavitation, but I'm just building this for proof of concept. I'd have to somehow equalize these ports to be able to move the same amount of water per revolution. Wow, this never gets dull. I love the way this PLA stuff prints out. It is nice and smooth, almost like it has an acetone bath or something. I don't know if I showed you. This is almost the final assembly, right? This ring goes in between here. I don't know if you've seen my video yet on the importance of the importance of knowing the tolerances and the printing limits of your machines and stuff. Well, this is sort of why. I'll show you. This print, since these two pieces sort of cover a wide area, the middle seems to be okay, but the sides seem to have warped up a bit. So that's why you see a clearance. I don't know if you can see it there. These are sandwiched tight together, yet you can sort of see there, you can see the gap there. So when I take my ring and I put it there, I'm left with a gap. It doesn't seal right, so I have to make this ring, the stator ring, over again, but a little bit taller, so I can close in that gap, so I can just epoxy it together, right? Because there's tight, and there's a gap right there. Well, thought it was done, but still a little more tweaking. This is my my design, my stator ring, my measurements, and it comes in at 26,162, and on my ring, if I measure it, I have 26,13. So I'm not far that off. I'm not that far off, but the thing is, I think I have to print it around 27 to get better results, because that's the measurement I'm getting now. When I actually measure the spacing between this cover and that cover. So I'm going to put 2710. Loose fit. 2710 I should be okay in case it shrinks a bit. That's the input shaft, and that's the output, I believe, and this is the input. Now I don't know if my drill chuck's going to fit between the input and the shaft. If it doesn't, I'm going to have to either put an extension on that shaft to get it to spin with the chuck, or actually redo this cover with a different with an elbow on here or something. I don't know if a flex tube can actually take that much bend and still work. So here we are back in the high-tech test facility. I'm going to test out the vane pump. Maybe empty hot or cold. I have a half inch hose here that'll fit on the connector, right? And if I'm not mistaken, this side's the output. So I'm going to try to prime it up with some water. Get some water in there. And now the drive tool. Oh yeah, it works. Boys, does it work.
if I can't get this. I'm going to have to make this part of the housing again. Probably have to do a whole new print, but I think I'm going to keep one of these for myself. See what I mean? It's already pumping. I have to make sure I can load it up with water. See? It works. Once it expands, no problem. Oh, yeah, it works. Success.